Hello friends, in this video we are going to study how we can determine a transfer function using a block diagram reduction technique. A complicated block diagram, it may consist of many loops, and these loops, they are interconnected with each other, and also a block diagram, it can have many number of feedback loops. So a block diagram is having many number of blocks, and these blocks are interconnected with each other, and also there are many feedback loops in a block diagram. So it becomes very complicated. So in order to determine a transfer function, that is the transfer function of the overall system, then we have to use a procedure to reduce these blocks, so that we use a procedure in which these blocks, they are rearranged. We rearrange these blocks using some rules, and this procedure, which is used to reduce the block diagram, is known as block diagram reduction technique. So in this video, we are going to study about this technique, that is the block diagram reduction technique, and what are the rules which are defined in this technique, so that we can apply these rules to find out the overall transfer function of a system. Let's study the first rule. The first rule of the block diagram reduction technique is how we calculate the output of a block. This is the block, and this block is representing a component of a control system. Now this component or this block is having the transfer function GS, and the input to this block is XS, and the output of this block is YS. So if we find out the equation for YS, it will be equal to GS multiplied with XS. So this is the output of a block. Now if we rearrange this, we will get the transfer function of the block as YS by XS. Okay, so this is how we find out the output of a block. So whenever we encounter a block in a block diagram, we can use this rule to find out the output of a block. Now the second rule of this technique is how we solve or how we reduce the blocks which are connected in series combination. We have already studied that how the blocks they are connected in series combination. When the output of one block is connected to the input of the second block, in this way if the blocks are connected, it is called the series combination of the blocks. Now here we have taken an example where the block 1, two blocks are connected in series and the block 1 is having the transfer function as G1s and the second block is having the transfer function as G2s. Xs is the input to the block, to the entire system, and Ys is the output of the system, or we can say output of the second block. The output of the first block is Y1s. Now if we draw the equivalent diagram, then we can multiply the transfer function of these two blocks. So these two blocks they can be replaced by a single block which is having the transfer function in which these two transfer functions they are multiplied, that is G1s multiplied with G2s. So whenever we encounter two blocks which are two or more than two blocks which are connected in series with each other, then we can replace them with a single block which is having the transfer function as the multiplication of the individual transfer function of the blocks. So Ys will be equal to Ys by Xs is equals to G1s and G2s. We can also prove this as, let us suppose we have known that the output of this first block is Y1s. So Y1s will be equal to G1s Xs Ys is Y1s multiplied with G2s. Y1 we have already obtained. So if we put the value of Y1 in this equation, we will get Y1 is G1s Xs so Ys by Xs will be equals to G1s G2s. So this is the proof of how we are replacing these two blocks connected in series by a single block having the transfer function G1s and G2s. So we can conclude it that if blocks are connected in series, the resultant transfer function can be obtained by multiplying the transfer function of all blocks. Now the third rule in the block diagram reduction technique is when the blocks are connected in parallel with each other. So how we reduce them in this technique, what is the rule? These are the three blocks which are connected in parallel with each other. The first block is having the transfer function as G1s, second block is having the transfer function as G2s, and third block is having the transfer function as G3s. Now this is the takeoff point. So the input signal Xs, it is applied to all the three blocks. So Xs is given to first block also, second block also, and third block also. Now the output of the first block is Y1s, second block is Y2s, and third block is Y3s. All these three outputs, they are summed up by this summing point, and collectively the output is Ys. So if the blocks are connected in this way, this is called a parallel combination of the blocks. So we can reduce this three blocks into a single block which is having the transfer function as the algebraic sum of the individual transfer functions. That is, the block, it is given by G1s, G2s and G3s summed up with each other. If these signals are having minus sign, then we will take minus sign for the summation, and if the signals they are having positive sign, then we will take positive sign here. So this output ys by xs, it is given by g1s plus minus g2s plus minus g3s. We can prove this also. Let's prove it how we get this. Y1s is equal to G1s xs, Y2s is G2s xs, and Y3s is equal to G3s xs. Now this output ys, it can be written as, because it is the output of a summing point, so it is given by the algebraic sum of the input signals. So it is the algebraic sum of the three outputs. Now put the values of y1s, y2s, y3s from these three equations. In this equation we will get in these three terms we are having xs as common, so it can be taken out. So ys will be equal to g1s plus minus g2s plus minus g3s, and we have xs as outside the summation. So ys and x by xs, it is given by g1s plus minus g2s plus minus G3s. So this is the proof of how we are replacing these three blocks which are connected in parallel by a single block which is having the transfer function as the algebraic sum of the transfer function of all blocks. So this is the point that you have to replace whenever you encounter blocks which are connected in parallel in a block diagram, then you can replace them with the single block which is having the transfer function as algebraic sum of the transfer function of all the blocks. Now let's study the fourth rule for the block diagram reduction technique. The fourth rule is that how we can interchange two consecutive summing points. Consecutive means that they are coming one after the other. How we can interchange them? This is the diagram for this. We are having a summing point A and a summing point B, and the input to this summing point A is x1s and also this x2s. The sign of this x2s is negative, so the output of this A summing point will be x1s minus x2s. Now this output is given as an input to the second summing point B, and here we are having the plus sign. So this signal, input signal, and this is also an input signal y1s. These two input signals, they are added up. So we are having x1s minus x2s plus y1s as the output of the second summing point. Now if we interchange these two summing points, That is, here we have B summing point and here we are having the A summing point. And inputs are also replaced, means you have to put this summing point to this position. So what will be the effect on the output? Let's see. Here also we are having the input as x1s. This is having plus sign, and the input to this B summing point is y1s. So the output will be x1s plus y1s. Now this is given as an input to the A summing point. The second input is minus x2. So we will get the output as x1s plus y1s minus x2s. So you can see that the output of the summing points in both these cases, when we are interchanging the two summing points, it is same. That is x1s minus x2s plus y1s, x1s plus y1s minus x2s. The output remains the same. So if two consecutive summing points, they are interchanged, their output remains same. So whenever you encounter two summing points in a block diagram, you can interchange them and the output, it will have no effect in it. So let's study the next rule. Rule number 5. This rule says that shifting of a takeoff point before a block, we are shifting the takeoff point which is present before a block to a position just after the block. Okay, so here let's see how we can shift a takeoff point. In this diagram, this is the block and this is the takeoff point. So let's study the 5th rule for the block diagram reduction technique. The 5th rule is how we can shift a takeoff point which is present before a block to a position just after the block. This is the diagram and it is the takeoff point. So this takeoff point is present before a block and we are shifting it to a position after the block. So this signal which is coming here, this is XS, and XS is given to both these blocks. This block is having the transfer function as GS and this is having the transfer function as HS. So we are getting the output of this block as XS HS and the output of this block is XS GS. So if we shift this takeoff point from this position to this position, then what will be the effect on the block diagram? You have to divide this HS by the transfer function of the block before which we are replacing or moving this takeoff point. We are moving the takeoff point from this block GS, so you have to divide the transfer function of this GS into this HS. That is, this takeoff point has been shifted to this new position and we are dividing the HS by GS. So what will be the effect on the output? XS, we are having the output as here XS GS and here we are getting XS GS as the signal. So if we multiply this with this transfer function of the block, that is XS GS, it will be multiplied with HS divided by GS. So GS will be cancelled out and we will get the output as XS HS. So there is no effect on the output of this block. So you have to you can shift the takeoff point from before to after the block, but you have to divide the HS by GS. So you can use this rule whenever you are using the block diagram reduction technique to determine the transfer function. You just divide the transfer function GS from HS. Now let's study the sixth rule, which is shifting of a takeoff point after a block to a position just before the block. Earlier we have studied that we are shifting the block from before a block to after the block. Here we will study the takeoff point which is after a block to before a block. Now this is the takeoff point. And we are shifting this takeoff point which is after the block to a position before a block. The input to the block is XS and output will be XSGS, and this same signal has been given to this block which is having the transfer function HS. So the output will be XSGS multiplied with HS. Now when you are moving this takeoff point, then you have to multiply the HS with the transfer function of the block, that is XS and GS. So let's see what will be the effect. The same signal XS, it is being given to this. So XS, HS, GS will be the output, and the output of GS will be same, that is XS, GS. So we are getting the same output in both the cases from this block. So you just have to multiply the transfer function. In this case, you have to just multiply the transfer function of the block. So keep this rule in mind whenever you are solving the question, that whenever you shift the takeoff point from a position after a block to a position before the block, you have to just multiply the transfer function of the block. Now the next rule is rule number 7. This rule is about the shifting of the summing point. Here we are shifting the summing point which is before a block to a position just after the block. Let's see the diagram for this. This is the summing point. And you have to shift this summing point from a position before a block to a position after a block. Don't get confused in what is before a block, what is after a block. Just see the direction of the arrows, because arrows show the direction of flow of the signal. So this is before, because the arrow is inwards to the block, so it is before the block, and this direction of arrow shows after the block. So what will be the effect? First let's see the output. This is the input X1S, and here we are adding the signal XS into S. The input to the HS is X2S, so the output will be X1S plus minus HS X2S, and this will be multiplied with GS. So this is our output. Now what you have to do, if you move this summing point from this position to this position, that is just after the block, then let's see what happens, what effect will be on the output. This is the input X1 multiplied with GS, so you are getting X1S GS, and this signal is added up or plus minus HS GS, and this is X2S. So what we are getting here? Now these two signals, they are given as an output, so we will get GS is common in both the question, both the output. So we are getting GS as common, and inside we will have x1s plus minus x2s gs. So in both the cases we are getting the same output. So whenever you shift the summing point which is before a block to a position after the block, you just have to multiply this hs with gs. Okay, in this case you have to multiply the transfer function. Okay, just remember this. Now rule number 8. In this rule, you have to shift the summing point after a block to a position just before the block. Here we are having a summing point which is present after the block, and you will have to shift this, or you want to shift the summing point before a block. So the input to this block is x1s and the transfer function is gs. So the output will be x1s gs, and in this summing point we are having this signal, and x2s is the input to this hs. So output will be x2s hs. Now you have to sum up these two signals. So output will be x1s gs plus minus x2s hs. Now if you shift this summing point before the block, then you have to divide the hs by gs. In this case you are dividing. So let's see what is the effect. The output of this is hs by gs multiplied with x2s. Now this and these two signals, they are added up, so we are getting x1s plus minus hs by gs into x2s. Just cross multiply it, we will get x1s gs plus minus x2s hs. So the output remains the same. There is no effect on the output. So if you are shifting the summing point before a block, then you have to divide the transfer function. Now the next rule is rule number 9. In this rule, if you want to move a takeoff point after a summing point, then what you have to do? This is the takeoff point. And this is the summing point. And you want to move this takeoff point from a position before the summing point to a position after the summing point. Now the input to this summing point is xs, and this xs is also given here because this takeoff point is giving the same signal as an input to another block, and the input to this summing point is xs and the second input is x1s. So the output will be xs plus minus x1s. Okay. Now when you move this takeoff point from before the summing point to after the summing point, then what you have to do, this summing point will be shifted here and you have to introduce another summing point here in this path. So what will be the input? Input will be the same. You have to just take the copy of this summing point and you have to put it here in this path also. So let's see whether our output is affected or not. So this is xs and we have shifted the takeoff point from this position to this position. So the output of the summing point will be xs and this is plus minus x1s. Okay, so ys will be same in both the cases. Now let's see what is there any effect on this xs. From here we are getting xs plus minus x1s. This is the signal. So the input to this summing point is x1s. So this signal and this signal, they will be added up. Okay. And here we are having the reverse of these signs. That is, we are having minus plus. Not plus minus, we are having minus plus here. So we are having xs plus minus x1s, and here we are having minus plus x1s. So this and this will be cancelled out because they are having reverse sign. Plus, and here we are having minus, so that will be cancelled. If we are having minus here and here we will have plus, so in that case also they will be cancelled. So the output is the same, that is xs in both the cases. So there will be no effect on the output. Just you have to introduce a copy of this summing point in this path also. But also keep one thing in mind, that here we are having plus minus sign and here we are having minus plus sign. So just keep it in mind. You have to take care of these signs also, and the output will be same in both the cases. So in this way you can move a takeoff point after a summing point. Now the next rule is rule number 10, that is moving a takeoff point before a summing point. First we have studied moving a takeoff point after a summing point. Now we will study moving a takeoff point before a summing point. This is the takeoff point, this is the summing point. We are shifting it from the position after to before. Okay, this is shifting to before the summing point. Input to the summing point is xs. We are having another input as x1s. This is plus minus. So the output will be ys equal to xs plus minus x1s. And this takeoff point is also taking this signal to another part of the block diagram. So ys is xs plus minus x1s. So when you shift this takeoff point, what you have to do, you have to introduce the summing point in this path also. Just the same what we have done here there, but the sign of the summing point is not changed. It is same. So let's see, is there any effect on our output? Here we are getting xs and this is x1s. So output will be xs plus minus x1s. That is same in both the cases. Now here this is xs, this is plus minus x1s. So output is xs plus minus x1s. Same in both the cases. So there is no effect on the output. You can shift the takeoff point from after the summing point to before position, and you just have to introduce a additional summing point in this path, and also the sign of the summing point is same. That is, sign is same in this case. Okay, so this is our rule number 10. Now the next rule is rule number 11. Now the rule number 11 is about how we can rearrange two summing points. First we have studied earlier that how we can interchange two summing points. Now we can see that how we can rearrange two summing points. So these are the two summing points A and B, and the input to this A summing point is xs and x1s. So the output is xs plus minus x1s, and this output is given as an input to the second summing point B. Second input is x2s, so the output will be xs plus minus x1s and plus minus x2s. Now if we rearrange them, we can bring this summing point downwards. Okay, this is A, this is B. Now in this case you have to change the inputs to these two summing points. This is x1s, it will act as an input to the second summing point. So here we will get the output as this is x1s, this is x2s. The output is x1s plus minus x2s. And this input and this input, they are adding up. Okay, so we are getting the output as ys equal to xs plus minus x1s plus minus x2s. Here we are having plus minus sign. So the output remains the same in both the cases. You can rearrange the summing points like this. If there are two summing points, you can bring the second summing point downwards, and the input to the second summing point will be these two inputs, that is x1s and x2s. So in this way you can rearrange two summing points in a block diagram. Now rule number 12. The rule number 12 is about how you can eliminate a feedback loop. If there is a feedback loop present in a block diagram, then how you can eliminate that feedback loop. This is the block diagram which is having a feedback loop. So this is the feedback loop present in the block diagram. Xs is the input and Es is the error signal. Es is equal to Xs plus minus Ks. Ks is the feedback signal. So Es is equal to Xs plus minus Ks. And this Es is multiplied with G1s and we will get the output as Ys. So Ys is equal to G1s multiplied with the error signal Es. Now this Ks, which is the feedback signal, it is equal to H1s multiplied with Ys. So we have got three equations of Es, Ys and Ks. In this equation for Ys you have put the value of Es, and in the equation of Es put the value of Ks. So what you will get, so if we put the value of Es in this equation and Ks in this equation, so what we will get, Ys is equal to G1s, Es is equals to Xs plus minus Ks is what, H1s Ys. So we have got the equation in terms of Ys, G1s, Xs and H1s. Let's solve this equation. This can be bring down here, bring it in this position. So when we are having plus minus, if it is shifted to the left hand side, it will become minus plus. Then we have H1s, G1s and Ys. Taking Ys as common, we will get 1 minus plus H1s, G1s, and in the right hand side we are having G1s, Xs. So if we take the ratio of Ys and Xs, it will be equal to G1s G1s upon 1 minus plus H1s G1s. So this is the transfer function of the system, if we have reduced this, eliminate this feedback loop. So we can replace this full feedback loop by a single block, and this block is having the transfer function as G1s and divided by 1 minus plus G1s H1s, and we have proved it also that how we are getting it. So whenever you encounter a feedback loop in a block diagram, just replace that feedback loop by a single block which is having the transfer function as this. Okay, so this is the rule number 12. Now let's see rule number 13. Rule number 13 is simple, the modification of the rule number 12. In the rule number 12, you have seen that how we can eliminate a feedback loop. Now, if this feedback loop is having a unity transfer function, that is Hs is equal to 1, then how you can eliminate a unity feedback loop? Now, this is the input Xs, and here Hs is being replaced by 1. Okay, that is this feedback loop is having the transfer function as 1. So what we will get, just we can replace the value of Hs by 1. Earlier we have obtained Gs upon 1 minus plus Gs Hs. So if Hs is equal to 1, then we can put here this value, so we will get Gs upon 1 minus plus Gs. So simply we are replacing the value of Hs by 1, and we can eliminate a unity feedback loop in this manner if it is present in a block diagram. Now rule number 14. Rule number 14 says that if the control system is having 2 or more inputs, then how you can solve this block diagram. Here we are having a control system which is having 3 inputs. This is also an input number 1, this is input number 2, and this is input number 3. And this is the output of the control system. So how you can replace this control system, or how you can solve this control system which is having 2 or more inputs? Let's first draw the block diagram for the first input. So for the first input we are having Xs, and this is the block Gs, and the output is Ys. Let's take that the output of this first input is Y1s. Now for the second input we are having X1s, Gs, and the output is taken as Y2s. And for the third we are having X2s as the input, then we have block this Gs, and the output is Y3s. Now if we sum up these 3 cases, that is we add these 3 block diagrams, then what we are getting? We are getting the same block diagram of this control system. So let's write the equation for these 3 diagrams. First we are having Y1s equal to Xs Gs. For the second we are having Y2s equal to X1s Gs. For third we are having Y3s equal to X2s Gs. So these 3 equations we are getting, and this output is the sum of these 3 outputs, that is Y1s, Y2s and Y3s. So Ys is equal to Y1s plus Y2s plus Y3s. So put the value of these 3 outputs, you will get Ys equal to Xs, X1s, X2s and Gs as common. So the same output we are getting here. If we take here the output, then what it will be? Xs plus X1s plus X2s, and we will multiply it with Gs. So what is the output? GS multiplied with so the same output we are getting. So we can, in this way, we can solve a control system which is having two or more inputs, and if it is present in a block diagram. So these were the rules in which we have to follow while we are solving a question in which we have to determine the transfer function or the overall transfer function of a control system. Let's keep these 14 rules in mind, then you can easily solve any question on the reduction of the block diagram. And let's have some key points which you have to remember while solving the questions. The first key point is that just first reduce the blocks which are connected in series. We have studied this rule, that how we are going to solve the blocks which are connected in series. When they are in series, you have to just multiply the transfer function of the blocks, of all the blocks. So first, if you are having a question, then just see the question and first reduce the blocks which are connected in series. So the block diagram will be simplified in some way. In the second step, reduce the blocks which are connected in parallel. If you are seeing that there are some blocks in the block diagram which are connected in parallel, then reduce those blocks. Okay, when the blocks are connected in parallel, you have to just add the transfer function. So then reduce the blocks which are connected in parallel. Now the third point is that reduce the minor internal feedback loops. If you are seeing that in the question you are encountering some feedback loops which are very small in size, that is the minor internal feedback loops, then first reduce them. So if you apply these three these 3 points in solving a question, your block diagram will be reduced in some way and it will be getting simplified step by step. Now the fourth point is always try to shift the takeoff point towards right and summing points to the left. We have the rules of shifting the takeoff point in both the directions and summing point also in both the directions. But just try to make that you are shifting the takeoff point towards the right and summing points towards the left. It will be easy to solve the question. Now the fifth rule says that use the rule number 4. The rule number 4 was interchanging two consecutive summing points. So whenever you are encountering that you have two consecutive summing points and you want to interchange them, use this rule if it is very necessary in the question. Okay, only use it in that case only, because it becomes difficult to solve the question when you are using this rule. So if it is very necessary in the question, then only use the rule number 4. Now the sixth point is that repeat these steps 1 to 5 till you get the simple form of the block diagram. Try to reduce, try to apply all the rules step by step, and then when you try to get the simple form of the block diagram. And the last step is use the feedback rule and obtain the closed loop transfer function ys by xs of the overall system. That is, you are getting the simplest form of the block diagram, and in that block diagram you are having a forward path transfer function and a feedback path transfer function. Then apply the feedback rule and obtain the overall transfer function of the system which is in the question. Okay, so whenever you are solving a question using the block diagram reduction technique, follow these steps so that it will be easy for you and you will get to the solution very easily. So in this video we have studied about the block diagram reduction technique and the rules which are which we will use to solve the questions to obtain the overall transfer function of the system. I hope you have understood the lecture easily. Thank you.